sitting there thinking, oh, I can't turn it around. Okay. I'm sitting there thinking to myself, why can't I figure out how to even approach why electrons persist? Right? Why atoms persist? You know. All right. Let's say that there's three components of an atom: proton, neutron, and electron. Right. Right. Oh my gosh. It's like a mathematical quandary, meaning the word atom means cannot be cut anymore. So if you have something like a board or a chair or a person, whatever, you cut in half and keep cutting smaller and smaller pieces until the last piece that you can't cut anymore, you can't make a knife sharp enough anymore, is an atom, right? Right? But it's like, when you think about that, if you actually cut and cut, right? This is just silly here. If you actually cut, and you get to the bottom, the last piece, right? Would the last piece be round, or would the last piece be a shard, right? Would the last piece be cut, right? Meaning a shape of an atom, we would imagine to be round, but the last piece cut from something would look like it was cut from something. That's all I'm saying. And it's just one of those things. You start from the bottom and it looks like a circle. It looks perfect. You imagine it's perfect. An atom is perfect, right? And a mathematically perfect atom is a circle, is a sphere. Blah blah blah, right? But if you were to cut down from a thing down to an atom, the last thing you have would not be a perfect sphere. I guarantee, right? Oh my gosh, the last thing that you would have would not be a perfect sphere, would not be even close to a sphere, I propose, right? Unless it's, the idea of the heap, the fallacy of the heap. If you have 2 grains of rice, 3 grains of rice in a pile, would you call it a heap, right? Together on the table, right? If you have 4, you add 5, maybe that's a heap. If you have 1,000,000, that would be a heap, right? Or 100,000, however many that much is, grains of rice. And the fallacy of the heap says that it's not that it's impossible, but by virtue of language, by virtue of deciding, you have to decide, is 167 grains of rice a heap? No, but 168 grains of rice is, right? Okay, if that's a heap, maybe 167 was too. You have to decide, and that's the fallacy there. And why is this interesting? This is the stuff that I tend to think about, right? I don't think about Kardashians. Unfortunately, I don't think about my daughter. I think about stuff like this. Every once in a while, I think about my daughter. Wonder what she's up to these days. Wonder if you can even see me, or if I'm on the ceiling. Anyway. Red Bluff or something. I was at the restaurant, and the waitress, I guess her name was Emily. It's on the receipt. Right? What a great name, Emily. She was so amazing. She was like a happy robot that was built just for me. An AI is so funny. I was having interesting banter with her, and she was keeping up with a smile on her face, like, wow, she has all the time in the world for me, and it's just amazing. Not that we talk very much, but it was just so fun to see. Again, it's like the whole world was made just for me, and there's another example of it. This young girl. I got to sing her airborne cadences. She liked that. Anyway, but she was like an AI. Just happy, which is amazing. You know. Oh, I asked her what there's to do around here. She said just a lot of restaurants around here in wherever we were at, Orland. But she said if she wants to do something, she would go to Chico. I didn't think to ask what she does in Chico, but I asked how far it was to Chico, and she said about half an hour. I said, yeah, it's like Grants Pass in Medford. Oh, funny. So why do atoms persist? I think if I was to design something like an atom, like an electron, it would be like the impossibility of numbering the numbers between 0 and 1, right? Numbering the numbers between 0 and 1. You can number the numbers to infinity. You start at 1, you go to 2 and 3, and you keep going forever, right? But going between 0 and 1, what's the first number you would even start with? 0.01, right? 0.001, 0.0001. You know, you could get smaller and smaller and never be able to even write the first number. So if the question on the table, if the job that I was tasked to do was to invent, was to design, was to build an atom where everything else was made from that, right? All right. If it was my job to build an atom, where would I even start, right? If I was as big as me and I was to build an atom as small as an atom, right? I mean, even silly. If I was if I existed, if I was the size of 100 atoms, right? 100 atoms. I exist and I'm 100 atoms, and I want to invent an atom that's around my size, you know, about an inch tall compared to me. Okay, that's what I'm saying. About an inch tall. Invent something that's an inch tall, right? Something I can see, right? If I was 100 atoms tall, right? But how do I want to approach this? How do I want to continue this? Right? To say, scientists would say, let's just say this, let's just establish, where does atoms come from? Who invented atoms? How do you build an atom? Okay. Scientists would say, this is what I'm asserting, scientists would say, is that the Big Bang happened and invented in 400,000 years, atoms began to express. Atoms formed after 400,000 years of swampy whatever, of no atoms, just they say energy, whatever, hot, they would say, right? And I think they would say that all the atoms that have ever existed or will ever existed was created in the Big Bang, right? And they get swapped around from this star to that star, and us here, we were created from the star, right? The offshoot of whatever star. Maybe the sun, maybe a star that died next to us, whatever. And here we are. The proof is, here we are, right? But the scientist would say that every atom is already made, right? Congealed 400,000 years after the Big Bang. Every atom, right? Even then, right? What is actually happening, right? What actually happened? what does it mean to make an atom at all, right? And to say, furthermore, that all like atoms act alike, and all atoms in general act alike, right? Except you say radioactive, whatever, blah, 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 and unstable atoms and things like that. I'm saying, to even say that an atom is unstable says you're acknowledging that the atom will dissolve, will fail, will disappear, right? And you say, oh no, it's unstable because it's boron and it becomes, cesium, whatever, or the other way around, whatever, to say, oh, the atom itself will always persist, so it'll just be another different atom, right? And even still, right? It's like a total fairy tale, right? It's total biblical nonsense to say this atom does this and that atom does that, and this atom has always been here and will always be here, right? To say, go back to my question, if I was to make an atom myself, right, and my boss, God, or Jesus, or Spider-Man told me what he wants in this atom, what he wants this atom to be able to do, or be able to do, and what's the difference? Be able to do seems like it has ability to do something, or do, it doesn't have to, I don't know, be able to do, is there a difference? Be able to do, right? Let's say God said, make me an atom, all it has to do is exist, right? All it has to do is persist, right? Even still, right? I go, right? I'm me, I'm 6 foot tall. I say, okay, God, and I go to a tree right here, right? Atoms don't exist, but God asked me to make an atom, and I go to a tree, I pull a leaf off of the tree, right? I say to God, here's an atom, it exists, and I say it will always exist, right? I show this leaf to God. I say, this is an atom, right? And Spider-Man says, God says, great, okay, now make, quadrillion, billion, million, billion of them, right? Whatever. So he confounded me. He caught me in my lie. I did not make this atom. I stole it from a tree, right? And he wants a million, billion of them. And oh my gosh, right? So let's say I take another leaf, right? I start my journey into amassing million, billion of leaves, right? And I notice I take 2 leaves and I hand them together, I put them together, right? I put the leaves together and they don't stick, first of all. They don't stick together, right? They don't stick together, right? So, did God ask me to make them stick together? There's another thing. That's a whole other series, a whole other career, someone's career, right? A whole other human race of philosophy, different than does it exist, as opposed to, will it stick to something else, will it stick to the next one, and guess what, the next one is exactly like the first one. There's another realm of indecency right there. The first one exactly like the second one, is it? Right? And do these atoms have personalities and so on, right? Do these atoms breathe? Do these atoms live? Are these atoms alive? Do these atoms live, and are these atoms alive? Is that two different questions? I think, that's the stuff I think about. Are they alive, right? How do you make these atoms continue, right? If you're starting from nothing, right, and you go into quantum mechanics, let's say that's true. Let's say quantum mechanics is true, and I say, I say quantum mechanics, I say fuzzy logic, they say the atoms, the atomic particles come in and out of existence. They just hop in and out of existence, right? And that's fine. The proof is we're here. We're here. Here's stuff, Whatever the atoms are doing is successful. Here we are, right? Until the moment that they're not successful, and we won't be here, right? Which is funner, to exist or not to exist? Well, we'll find out. Which is funner. So the atoms, right? Quantum mechanics. Scientists are falling back. Scientists are using the scapegoat of the concept of quantum mechanics to explain what atoms are. And I say, how about this? Here's a new idea. Okay. Let's say there's a tree, you cut the tree, cut, and the last thing you can't cut is an atom, right? Okay. And I go back to the fallacy of the heap to say, physics right now is binary, right? There's large things, sufficiently large things, like stuff we can see, that's dealt with Newtonian physics, right? Classical physics. And there's stuff that's too small to see. Stuff that's too small to see, that's considered in the realm of quantum mechanics, right? And I say, let's say that there's a point in our focus between the classical physics and quantum mechanics, right? A point of focus, meaning the atom is acting in the world of quantum mechanics and we are acting in the world of classical mechanics. And between them is the line, the threshold of everything smaller is quantum mechanics and everything bigger is general classical mechanics, right? So I'm just asserting that what I'm asserting is if you cut something you can see down to something you can't see, right? The last thing that you can't cut still isn't the size of an atom. That's what I'm getting at. The last thing that you can cut still is the size of an atom. An atom is even smaller, as silly as that is. And so there's a whole piece of the spectrum of distance between that last thing you can cut and atoms, right? Maybe there should be a word for that threshold, that, what's it called? And black holes have that event horizon, right? The event horizon, that's what I'm saying, right? The event horizon between classical mechanics and quantum mechanics. That's what I'm saying, right? And what's it matter? what's it matter, right? To say, if you invent one atom, right? You haven't invented a thing that does something, right? You've invented an atom. This is where I'm going with this. And if you invent enough atoms to build something to the size of the event horizon, then that's big enough to exist, to do something, to sit there and hold down paper, to say, well, this is kind of a different idea, a different direction to say, stuff that's smaller than the event horizon is doing something different than stuff that's bigger than the event horizon. It's in different universe, literally different universe, and that's right, a different universe. The stuff that makes up us, if you go down small enough, you're in a different universe, and you could say multiverse, whatever, but I'm saying different plane of existence, and at face value that makes sense, but what's that mean? Okay, so different tangent again, right? To say, I exist, here I am, you can hear me, right? I exist. And apparently I'm going to die. Everyone does, right? I was born, I exist, here I am, and one day I'm going to die. Right? What does it mean to exist? Blah, blah, blah. Is existing interesting at all? Right? I mean, my original question was, why do atoms persist? Right? That means, what I'm saying, of course, is an atom exists right now, right? I exist right now. An atom exists right now. And in 1 second, it will still exist, right? And for lack of a better word, I use the word persist, right? Why do atoms continue to exist, right? Why do atoms stay alive? Why do atoms continue to exist? How do atoms stay alive? Right? Oh my God. Cottonwood. Why do atoms stay alive? Why do atoms, right? I've touched on some videos of people explaining quantum mechanics and atoms and things like this, right? I've touched on the videos. And sometimes they say, oh, to understand, you would have to understand quantum mechanics, right? And I say, if you say that, it means you don't understand it well enough to explain it classically, yes, sure, there's a top spin, a charm, quark, and things like this, right? These are new words. Let's say top spin means something, right? Top spin, right? They're saying the spin of a quark is important, right? And they're talking mathematically, right? Is it? There's 6 different quarks, and how they spin matters, right? And I say, what's interesting to me is how they exist at all, right? How if you say that they spin, what makes them spin? And they say, oh no, spin isn't the right word. We're just using that as a placeholder. They don't actually spin, right? Okay. and is not actually top and it's not actually charm, but we're just using these as placeholders, right? So so that maybe that's the answer. I'm fleshing out the answer is to say these people who have spent years in rigorous research and contemplation, the best they could come up with, my idea, right, my question, why do atoms persist, the best they can come up with is that quarks have spin and some are top and some are charm. I think I'll end there.